Hey YouTube, what's going on? You're on GCSE and IGCSE. This is explanation of transformation theory. This is transformation applicable to geometric objects. That's why it's called transformation of shapes. And let's have a dialogue about translation. So in other words, for this sort of transformation, this is a slide. All right. If you're familiar with how to translate functions, that's would be very useful skill in order to translate objects, because it's all about geometric objects. So I think that the idea of how to translate functions will be very useful here, so that you can apply those skills to geometric objects. All right, so translation means slide. So basically you take in an object right here and you translate the whole object without not changing shape, not changing sizes, to some direction. In that case, as you can see, here is translation to the right. So that's why, for example, we can mark this vector. As you can see, that translate the top or the peak point or the peak vertex of the triangle to the right by some units. That what is called vector of translation. In this case, because it's horizontal, it has only x coordinates, and x coordinate is positive definitely, but y coordinate is 0. So you can mark, let's say, some translation by x units and 0 for y. But generally, vector of translation should have both x and y coordinates. So what it means that if you take in the vertex of the triangle, you need to translate by x units, as in this case, to the right. So number of units tells you how far you need to put your point. And you do the same with all vertices. So another way to say that the shape or the object has been translated by, let's say, some units to the right, you just simply need to shift every single vertex of your shape. But shape might be different, it might be a circle. So in this case, you translate the center, for example, by some units to the right. That's going to be horizontal translation. And you keep the radius the same. So you can apply whatever object you have. In this case, and most often, you will have deal with standard geometric shapes like triangles, rectangles, maybe some combined shapes like compound shapes. But the idea is pretty simple. So you take in a vertex of, you take in each vertex, translate by a vector of translation, and that's how you can get the image. So what you've got, finally, you'll have the image. So the image will have the same size, the same proportions, and basically it's going to be the same identical object's clone, but shifted somewhere, means change position in XY set. Okay, to understand how it works, let's go to some examples. For example, you can see triangle ABC. You need to translate your triangle by a vector with coordinates -1 and -2. As you remember, vector of translation V should have x and y coordinates. So the top is x, how many units you need to move your object horizontally, and y, in this case it's -2. It's vertical translation. So you need to state the coordinates of each vertices. So let's do that first, and let's mark our new triangle. So let's mark our image as triangle. So let's mark as triangle A prime, B prime, and C prime. Basically new vertices. All right, because each coordinate has been changed by the vector of translation, so you might work out the rule for how to get each coordinate for, let's say, for the point A. So it's basically the previous coordinates or the previous point shifted by a vector of translation B. All right, so how to work it practically? So we know that in our case, let's have a look at A coordinates. So point A has 5 for x and 8 for y. So what it means that on top of that to 5 and 8, but better to use the column. To 5 and 8, you need to add coordinates of the vector of the translation. So in our case, you basically add in the top x coordinates with each other. That's how you can get 5 plus minus 1, okay? And 8, so also -2. So that's how you can work out A prime coordinates. In our case, it's going to be 4, and 8 minus 2 is going to be 6. So once you got the coordinates for new vertex A prime, you can set up your A prime on Cartesian plane on XY set. So let's have a look. Now it's going to be 4 and 6. Your point A is going to be A prime. It's going to be there with coordinates, with new coordinates, 4 and 6. So by the way, normally we use column notation for vectors. So for coordinates, we use like, instead of writing 5 and 8 as column, so we better write 5 and 8 for the point A in a horizontal way. So that's how you can differ the coordinates from the vector. Okay, so let's move to the point B star, or sorry, B prime. In that case, I'm not gonna signify and put more details to that, but let's set up B coordinates that it has originally. So it's 2 and 4. So on top of that, we need to add -1 and -2. That means new coordinates for B prime is going to be 1, and -2 plus 4 is going to be 2, okay? So that's how we can get B prime coordinates. It's going to be 1 and 2, so it's right there. So that's B star. So B star with new coordinates, sorry, B prime 1 and 2. Sometimes I use, instead of prime, I use notation using stars. Okay, and in the full analogy, we can work out C prime coordinates. So for C prime, let's mark coordinates C, point C. So point C has the following coordinates, 8 and 2. So 8 and 2. That means on top of that, if you add -1 and -2, you will get 7 for x and 0 for y. So that means C prime will have 7, it's right there, and 0 equals, and y equals 0. So that's going to be C prime coordinates. So C prime with 7 and 0, we will set up here. Okay, what to do right now? Just using, let's say, maybe that's pink one, that's good. We just connect those new points, new vertices with each other, and that's how we can form new triangle. That's going to be the image. As you notice, each side of the new triangle is parallel to the side of the original one. So that is going to be the object for, so that's going to be the object, and that's going to be the image for our new triangle. As you can see, if you, for example, want to show this vector of translation on the diagram, you just can randomly select any vertex. Let's say in our case it's going to be C, and you put the vector down to C prime. That's how you actually denote that the vertex has been translated by the vector v. So in our case, vector translation v has the coordinates -1 and -2. And exactly, let's have a look at the components of the vector. Just remember vector topic. You can always complete your vector using the addition. So let's have a look. The horizontal shift for point C occurred by -1 step, so it's right there. So this is one component, and also vertical step by 2 units down. So this is another component. So you can, using those consecutive translation, you can work out the final position of each vertex using just idea of horizontal translation and vertical translation separately, and finally you combine that. Okay, so you also need to answer the question by which distance each point A and B and C have been moved. Okay, so what it means? It means that you need to work out basically the distance or the magnitude of the vector. Okay, so in other words, you need to work out the absolute value for the vector of translation. And as you remember, because there's the shift -2 units down, and here is -1 unit horizontally. Have a look at the coordinates. So we can use the formula for how to define the length. So basically this is Pythagoras theorem. If you have a look at this small triangle arranged by vertical translation by -2 units down, horizontal translation by -1 unit to the left, and hypotenuse, which is the resultant vector of translation, you can work out the length of vector v as the length of the hypotenuse. Basically, you apply Pythagoras theorem, okay? That comes from there. And that's why you're eligible to use the distance formula. So -1 squared plus -2 squared. So all negative values becomes positive, and that means you can work out the distance. So 1 and 2 squared is 4, so it's going to be square root of 5. If you want, you can work out the square root of that, but I use the third notation, and that means you work out the distance by which each point has been moved. Okay, so I hope this example clarified a lot about how to translate. In the revision topic, you'll see many examples of how translation can be worked out, and even not only for just objects, geometrical objects, but I'll also show you how to apply this translation to the function. That's going to be sort of rehearsal, and it's going to be good for you. All right, so hope you like that. Don't forget to subscribe if you're new here, and see you next time.